My presentation today is titled The Quest for Miniaturization, Innovations in Portable Operating Equipment. And my goal today, well, first let me introduce myself. I'm Adam, Kilo 6 Alpha Romeo Kilo, and I'm a mechanical and quality engineer by day. I hope that latter half of that doesn't cause too many of you to shudder in fear or hatred. So I'm also a content creator like Hayden. I create YouTube videos, although I haven't been too active in it in it lately just due to busyness with other things. I'm also a climber, a backpacker, and search and rescue member, and really a non-stop tinkerer. And that is kind of my goal today, is to show you some of these projects that I've done, some of these things that I've created and designed, and how I've come to those solutions to those problems, and hopefully inspire some of you to solve some of your problems in a similar way. On the right-hand side of the screen here is my QSL card. If you've been able to make a contact with me and either requested or sent a QSL card, you very well may have gotten one of these back in the mail. There's a little story behind this that I'll tell quickly. I was out hiking in San Diego County here, Southern California, with my sister one day. She was visiting from out of town, and we went up to a local summit. And of course, I had to bring my little mountain topper MTR 3B and a small magnetic loop antenna that I'll talk about a little bit later in this presentation. And I operated for about 30 minutes, which of course incited a bit of boredom in my poor sister as she waited for me to tap away at CW there. So being the graphic designer that she is, she took a picture of me, and on her iPhone, she came up with this design of a bobcat jumping through my magnetic loop antenna while I was sitting there operating. And she showed it to me, and I said, you know, that magnetic loop antenna really needs to be on fire and have flames around it. So there it became my my QSL card. Now, last time I presented here, I talked about the transceiver that's on the left there. I like to refer to it as the choking hazard, and it's essentially a surface mount device-based Pixie transceiver, and that is your standard 15 amp Anderson power poles there right next to it. So that's a good comparator to indicate the size there. On the right-hand side are some of my antennas, antenna matching units or balun that I have designed and sell as kits these days, which I also talked a little bit about last time in my presentation. And my point with kind of showing and comparing these is that there are a couple of different aspects of miniaturization and design and tinkering that I embark on, some of which are more to the extreme end and perhaps a little bit less, functional or practical. And others are, and I would say really most of what I do is trying to solve a specific problem that's going to help me out in my portable operating. So that Pixie transceiver, yeah, it works. I can make contacts on it, but it's not something I'm going to bring out into the field regularly for a SOTA activation. It's just not a high enough performing transceiver to be worth doing that. So kind of reviewing a little bit about these minimal antennas, and this is really one of the places where I got a big start in doing ham radio related design and engineering, and really creating some new products or new items that would be really helpful for portable operating. And essentially, to recap, what I came up with was an antenna matching unit that you build right onto the BNC itself, which produces a very small package that's ultra portable and sufficiently effective and efficient for a lot of the portable operating we do. And that was kind of one of the main topics, and the evolution of that was a topic of the last presentation I did here at the Tassie Ham Fest. Now, those little antennas that I build need to go on some kind of winder, and probably 5 to 10 years ago, when I was building more of these antennas, I was looking for a good winder to put 66 feet of wire, a 40 meter end fed half wave on of say 26 gauge wire. And I found a couple of injection molded solutions. The one on the upper left is about, 20 millimeters, I'm sorry, 20 centimeters long. The one on the bottom right is about half that. And the bottom right one actually works pretty good for 26 or 28 gauge wire for a 40-meter end-fed half wave. But the source that I had to purchase those things kind of dried up. They just stopped producing them, and I couldn't find any more of these kite string winders that were just perfect for antennas. And that was really one of the things that incited me to eventually buy a 3D printer. I decided I wanted a good solution to be able to design and produce antenna winders that were really optimized for amateur radio operators and for portable operating. So this is one of the first designs that I came up with, and this was really my introduction to 3D printers, which I didn't know would be such a doorway into kind of just an amazing opportunity for amateur radio accessories and innovation. So this winder that I've got a tray full of here, 12 of them on the bed there. I actually had intended to start selling these, and I sold a few of them. I mostly gave them away to friends. And this is very similar in size to that original injection molded winder, about 10 centimeters across. This is the winder next to a KX2, and you can see that I kind of specifically designed it to be about the size of the radio to fit into the box. A padded case to carry that KX2 around with this antenna tucked in next to it. And you might notice a couple things about this. You'll see the clip for the BNC connector there, which was a really handy way to secure the BNC connector to the winder. And you might also notice something about how the wire kind of sits on that winder, and that's pretty common for a lot of these winders that are shaped that way. It's kind of wrapped at an arc shape or a curve around the front of the winder. And after a bit of use of this winder, I decided, that this really isn't the most efficient or effective way to get the wire on the winder. And on top of that, the angle of the legs where the wire wraps around at each end of the winder, it just didn't allow for the wire to easily flow or slide off of the winder itself. And I'll go back to these original ones that I was using that were injection molded, and you'll see that the shapes are kind of the same. So I just kind of initially copied those designs, but I learned pretty quickly that, hey, maybe this isn't really the best shape for these things. So I got busy in Fusion 360, which, by the way, if any of you are interested in pursuing some CAD modeling or 3D printing design, it's a really effective tool, and it's actually free for individual use, which is pretty handy. I started with the next iteration being this lower left wireframe winder design to try to cut some weight from my winder, but I still found that even with the shape of the sort of midsection of the winder, the wire still bulged a bit, and the shape of the legs just didn't allow for the wire to flow smoothly off of the winder. So the next design was the one on the lower right here, where I straightened out the legs of the winder a bit. I thinned out and straightened the midsection of the winder, and I included that same BNC clip and even incorporated one for a female BNC connector in a later model. Up at the top center is just a wireframe version of the winder that cuts just a little bit of weight. So again, kind of going back to one of the original smaller winders that I had designed with some 30 gauge wire and 40 meter end fed half wave there with the small matching unit. And then a comparison, or for comparison, one of the winders, the newer designs of winders with the straighter legs, the thinner midsection, and you can see in comparing these two winders how much nicer the wire sits on that winder and gives really just an optimized tool for the job. Another really great thing about these winders is that with a 3D printer, you can very easily scale your prints up or down for various wire sizes or wire lengths to allow storage of different size antennas. So these winders, let's see, let's go back to this image. All of these winders, the wireframe version on the top, the wireframe, I believe, on the bottom left, and the ones with the BNC clips on the bottom right, are all posted on printables and are free for use. You can find the 3D models for those on k6ark.com. There's a link over to my printables page, and I would encourage you to check these out and go print up some of these winders for yourselves. You may also find that in these you have some ideas for your own. Some others have taken these wire winder designs and optimized them for their own use. Some people like having the matching unit attached to or mounted onto the winder. I prefer not to do that because of the way I typically set up my antennas. But some others have taken my winder designs and done variations of them that involve either a two-sided winder, so you can wind wire on both sides, and or included the matching unit directly onto the winder itself. Now, wire antennas are great when you've got enough space to set up a full wire on a summit, and you get a good amount of efficiency out of those wire antennas. But sometimes, like that summit that was on my QSL card, you're surrounded by shrubs or trees, and you simply can't easily get a wire in the air. And summits like that are great for a small transmitting loop or magnetic loop antenna. Unfortunately, a lot of these magnetic loop antennas are kind of heavy and bulky. Even the Alex loop, which is designed as a portable version of one of these antennas, uses LMR 400 style coax, using the shield as the conductor for the large outer loop, and involves kind of a telescopic pole as a frame to support that loop. So I didn't want to carry something that big and heavy up to summits. I'm a gram counter when it comes to backpacking and hiking, and I want to minimize the weight of my pack. So I started thinking, how can I create a conductive loop for that outer loop of that antenna using materials that I have available either at home or at a local hardware store, but make that loop so it's both something that I can collapse and break down to a smaller package, have something that weighs a relatively small amount, and something that's ideally a self-supporting loop like the Ciro Mazzoni loop on the right-hand side of the screen. So the initial solution that I came up with was to take aluminum tent poles from a tent that had lived its life well in the mountains, and the nylon tent itself and rainfly were delaminating and falling apart. So I took those remaining tent poles and took the shock cord out of them, the elastic cord out of the center, used a pipe bending tool to further bend those tent poles into a little bit tighter of a bend and make them so I could form them into a loop, which would also detach and collapse down. And I ended up building this magnetic loop antenna using that tent pole as the conductive outer element. Well, the first time I put that all together and tried testing it, and this was, as you can see on the image there, fed with a smaller inductive feed loop at the upper side of the loop there. The first time I set this up, it just wouldn't tune at all, and I was trying to understand what the problem was, and I pretty quickly found out that those anodized tent poles were actually not conductive at their joints. Because of the anodized coating, they were insulated from each other. So I had to come up with a solution to that problem. The the solution for the sections of the pole that had the insert already in it that would fit into the next pole section was a little bit tricky because those inserts were already pressed into the pole and weren't something that I could easily remove. So I drilled crosswise through the pole at those ferrule junctions and inserted an aluminum rivet and crimped that rivet into pop rivet into place to give at least a decent amount of electrical conductivity from the connecting pole to the junction piece, the ferrule that fits inside the next pole, and then inside the female portion of the next tent pole, I took a Dremel tool and a bit of sandpaper and simply ground off the anodized coating. And it actually ended up working fairly well. I was able to get the loop to tune up, and the conductivity was sufficient at those joints to have a halfway decent performing antenna. This image here is out on a local summit, and down at the bottom of the loop there, I was using a large-ish air variable capacitor. I want to say about 160 to 200 picofarads to tune the loop. And what I found was that I had a really hard time fine-tuning to get my SWR down on a specific frequency or even in a specific portion of the band with that one relatively large air variable capacitor. So I came up with an alternative solution. The tuning box on the left was the first iteration, and it involved a series of switches with fixed capacitors that I experimentally measured to figure out how much capacitance I needed for the middle of each of the bands I wanted to operate on. And by simply switching one or two of those switches, I would insert enough capacitance that would get me into the band, and the small air variable trim capacitor with the wooden knob on it there, I think 5 or 6 picofarads, would allow me to tune across the band with a bit more precision. It was a lot less fumbly than the large air variable capacitor that, with 1 degree of turn would shift by, say, halfway across one of the HF bands. So this gave me much better control. So initially I built the box with the ceramic disc capacitors on the left, and it tuned up fine and was usable with an SWR, I'm sorry, an antenna analyzer. But when I started to run some power through it, those capacitors didn't have the temperature stability to be able to maintain a consistent enough capacitance. And I found that as soon as I started transmitting, my SWR would climb and increase to the point where it was not really appropriate for the transmitter. So I dumped those ceramic capacitors and put some of the what are these called? Silver mica capacitors that you see on the right-hand side of the screen, which are much more temperature stable and provided sufficient stability to be able to operate on that loop. That loop ended up working out fairly well for me. I operated with it on quite a few summits and had some good success with it. But those aluminum tent poles still had a decent amount of bulk and weight to them, and I wanted to pare things down a bit more. So I thought, what else could I potentially use as a conductive material for that outer loop of the magnetic loop antenna? And I came up with some 1/4-inch thick by I think 3 foot or 1 meter-ish length bar stock aluminum available at the local hardware store. Cut that down into about 10 or 15 centimeter sections that I then joined with some hardware, with some nylock nuts so they wouldn't loosen, and that allowed me to create a loop that I could sort of accordion fold down like, kind of like those meter sticks that you've seen in the past that had a bunch of joints along them. and you would kind of zigzag or straighten them out to either expand or contract them. And this loop works by extending all of those aluminum elements out into a long strip, bending it over into a circle, fixing the ends together at that same matching unit that I showed you on the last magnetic loop antenna. And then in this case, the feed was essentially a gamma match with the ground at the bottom of the loop, and then the center conductor going to that small piece of wire and an alligator clip out partway around the loop. I created a little PVC pipe fitting that would hold or was bolted on to the bottom of the loop, and in that I had a piece of wood with a drilled hole that would allow me to set the loop right on top of an upside down hiking stick or trekking pole, and which is something that I'm generally going to have with me anyway on one of the mountaintops. So that loop ended up working out quite well. This is another iteration of the Matchbox with a 3-position switch that allowed for operation on 15, 20, and 40 meters with roughly a 1 meter diameter loop. And I'm not going to try to claim this antenna was all that efficient, but it works well enough to radiate. And I've got a video on my YouTube channel showing me working JG0AWE in Japan from a local summit here on 40 meters with this roughly 1 meter diameter loop. And certainly that was helped with some good propagation conditions, but with 5 watts and a 1 meter diameter loop on 40 meters, that's arguably less than 10% efficient of a radiator, we were able to get the job done. So it turns out to perform quite well, and it's a lot of fun to use. The total weight of this antenna is right around 500 grams. So it's actually, no, I think it's less than that. It's probably closer to 350 or 400 grams. So it's quite a small and light little antenna. So another kit that I optimized for portable use, and this will kind of showcase a few different projects and builds and innovations that I came up with to really optimize this kit for portable backcountry use. This is a Mountain Topper MTR-2B, the 2-band version of the Steve Weber Mountain Topper radio. It's about the size of a deck of cards or a pack of cigarettes, and you can see the 9-volt form factor battery there that I used to supply this. You can see the downsized antenna winder there with an RCA connector for the matching unit, which is the standard connector on this rig. And you might notice that even though this is a CW rig, there is no paddle to go with this kit because the paddle is built into the rig. It's a capacitive touch key that's based on a design, I want to say Mike 0 Uniform Kilo Delta M0 UKD, I believe was the original design that I borrowed the schematic from and made some modifications to it, including a voltage regulator and some different capacitive touch key kits. But again, you can see the size of the capacitive touch circuit here, which does a fine job of making this capacitive touch key, and the acorn nuts on the corner of the rig to supply the touch points here. So that capacitive touch key allowed me to really downsize the station and the rig, and again you'll see the 3D printed case here that cut the weight of the kit by a significant amount. So looking at some additional 3D printed innovations and designs related to antennas, I wanted to add some links to some of my antennas to bring on some additional bands. And the typical designs that I would come across involved, say, Anderson power poles and some PVC, or a little 3D printed or plastic spacer and some alligator clips. And none of those really fit my use case of wanting something that would be as small as possible. So I came up with a simple 3D printed design that uses some of these 2 millimeter banana plugs that are pretty readily available and gives the ability to wind the 26 gauge wire in this case through the device and have the 2 millimeter banana plugs in place in this link to give a very simple way in a exceptionally small package to add a link to an antenna and bring on some additional bands. You can find this on the printables page through my website as well if you're interested in building one of these. I don't operate single sideband a whole lot, but when I do, I don't like carrying the big Elecraft microphone with my kit. It just takes up a lot of space. I have to use a larger package to carry the rig in, and I wanted something smaller. So initially, I took an old Baofeng microphone, the little earpiece microphones that come with the rig, cut the earpiece off and modified the connector so I could use it with the KX2 or True SDX or other small single sideband rigs. And that worked well enough, but eventually I decided I wanted to design a purpose-built device for the KX2 and other rigs. So I came up with this mini microphone design. 3D printed case, just a simple electret microphone element. I don't have any capacitors or filtering in here, which might help a little bit with some of the low pass characteristics and improve the audio, but it seems to work well enough with just a small switch there on the side, and it downsizes the kit. Again, these are available on printables if you want the bill of materials and decide you'd like to build one of your own. Here's another look at that with some of the 3D models and the interior wiring that goes into that kit. Paddles. The left side of the screen there is the Palm Pico paddle. The Palm Pico was really kind of recognized as one of the best and optimum paddles to have for portable operators. And they became very hard to find over the years. They were discontinued by the manufacturer. And I see your message there, Hayden. Thank you. The being discontinued, I wanted to optimize the availability for folks and see if I could come up with something similar. And on the right-hand side of the screen is the Palm Pico design that I came up with. Let's see here. Come on. There we go. And these are the 4 pieces that go into this design. And really the key innovating feature here that I had never seen before in a 3D printed paddle was how I designed the hinges on these. Most of the hinges in 3D printed paddles rely on hardware, sometimes bearings for the pivot point of the levers. And without including bearings in a paddle, you really don't end up with very good feel to the paddle, and it doesn't end up functioning all that well. But what I discovered in that original design and subsequent paddle designs was that if we design these levers to pivot to have a hinge point that's just a thin section of plastic, of 3D printed plastic, you end up with a paddle that actually functions really well. You get a very controlled movement in the paddle and a very functional hinge point. So I'm going to move quickly through these to get you guys onto your tee. And but I want to show a quick image here of the variety of paddles that I've come up with, including a single lever, the retractable Palm Pico imitation paddle, some single lever straight keys on the right hand side here, and the relative size with a KH1. So the hardware that goes into these paddles is incredibly simple and cheap. A couple of M3 set screws, an M3 machine screw, maybe 50 cents worth of plastic, if that, and a headphone jack, a simple 3.5 millimeter headphone jack. So with a 3D printer or a friend with a 3D printer, perhaps, you can very easily build these paddles for almost, almost nothing, just perhaps a few dollars a piece. So I'd encourage you all, if you're CW operators, to look into building some of these paddles for yourselves. I'm going to skip ahead to the end here, um, and go ahead and wrap up. Let's see here. Uh-oh. So my challenge to you all is to take some of these ideas, take some of these concepts and some of these tools, and do some of your own experimentation and innovation. See what you can come up with to solve some of your problems and optimize your operating, so so you can have more fun in the field. And I also encourage you to share those ideas with others. There are a lot of ways to do that these days, whether it's through YouTube videos on printables, if it's a 3D print related thing, and other sources like GitHub. So it's just a really important part of the ham radio community that I really enjoy. And I just encourage you all to do some of the same tinkering, developing, and building and share with others.